and welcome. We are glad you have joined us. My name is Amit Neum. I'm a Microsoft technical trainer specializing in security and AI. I am here to walk you through the AZ-305 course, Design Infrastructure Solutions. In this session, we'll cover Design and Application Architecture Solution. We will describe message and event scenarios, design a messaging solution, design an event solution, design an application optimization solution, and application lifecycle. So let's get started. We start with describing messages and event scenarios. When we're referring to events, we have a publisher notifying something has happened, an event. It does not assume handling of the event. We can handle multiple events with option for analysis over time. Consumers can receive the event if they subscribe. From messaging perspective, we have another publisher that sends a message. This one assumes that someone will receive it and handle it. We can assure receive and delete mode, so every message will only be handled once. We can maintain first in, first out with multiple messages. The consumer, in this case, expects the message to arrive. So, an event is a notification. Something happened. A message is the payload, the actual data that must be handled. Suppose you have a social web app with user authentication enabled. A user logs in and your app broadcasts Amit is online. Is the login notification an example of a message or an event? Well, if nobody listened, the login will still be successful. That's an event. Now, let's suppose that our app lets users manage their own accounts. So users can sign up, edit their profile, and delete their account if necessary. When a user deletes their account, your web service notifies your data layer so the user data will be removed from the database. Is the delete account notification an example of a message or an event? Well, the delete account notification is a message. If the data layer doesn't remove the user's data, your system breaks. So, delete notification is a message. Let's design a messaging solution. We can plan for Azure Storage Queues. This is a simple storage solution that comes with huge scale with a simple model, accessible through the REST interface and built for your backlogs of asynchronous work. How does it work? The producers will drop messages into the queue. Consumers will pull them whenever they're ready, one by one or in a batch. Let's take e-commerce order, for example. The web app will write the order detail into the queue. A backend process can pull them in the background so checkout stays fast. We can also plan for a delivery solution called Service Bus. Think of terms of capability. Do I need first in, first out guarantee? Do I need unified transactions? Do I require push-style delivery? Dead lettering? Service Bus is about delivery. With basic queue, the consumer pulls the message. With Service Bus, the platform can support stronger enterprise messaging patterns, and you're typically designing for reliability and control. It will deliver the message. We can choose between two options. We have the Service Bus queues, where we have one sender and one receiver. Messages can sit and wait until the receiver is ready and being transformed as one transaction. We can also plan for Service Bus topics. We can publish once and multiple subscribers can receive the messages by their topic. The benefit here is better guarantees, richer features. It is a better fit for business-critical workloads. For example, a sports newsfeed. One publisher sends an update, and multiple agencies subscribe to that topic. Let us summarize the decision-making. We will use a queue storage when we need simple organization, extremely large queues, tracking progress, and a storage tier-enabled SLA. We will choose service bus queues when we need FIFO, at least once or at most once receive models, unified transactions, batching, and less pooling. We will choose service bus topics when we need a one-to-many distribution with multiple receivers. For example, producers can post a large number of messages that are received by many consumers. We can use a message broker to distribute processing across the servers and improve throughput. The consumers can run on different servers to spread the load. They can also be added dynamically to scale out the system when needed or removed otherwise. Now, we move into design an event solution. Azure Event Hubs is a fully managed real-time ingestion service. It is built for streaming millions of events at a second. How does that work? Events land in partition. Consumers read using a pool model, and ordering is based on the time offset as they are received. What is the main consideration for the pool model provided by the Event Hubs? Pool models make it the responsibility of the consumer to ensure data is processed before it's expired. This provides us flexibility, but it can also mean that messages might be lost. Event Hubs is the native option to integrate third-party solutions from monitoring and security perspective. It can ingest the telemetry to external SIM system or monitoring solution. This is an example for serverless event-driven architecture. An event generator sends an HTTP request to Event Hub. Event Hub will stream the data and trigger a function to debatch and filter. We will enable dead lettering for failures, then send the output to Event Hub. That will trigger another function for transformation. Again, dead lettering for failures, and we will update the Cosmos DB. Azure Event Grid is an event routing service. It connects event sources into event handlers. When X happened, call Y. How does that work? Sources publishes events. Event Grid will route them to handlers to react for things like functions, logic app, automation accounts. An example for serverless architecture. A blob is being uploaded into a blob storage. Event Grid will trigger a function to watermark the image. Logic app can send an email. Your upload is processed. Another example for ops automation. Let's say that we install an application via command line on a virtual machine. Event Grid will trigger automation account to add identifying tag to the resource. This comes with a huge benefit for reactive architecture that is serverless-friendly, automation-ready, and ready to service for all of our reactive needs. Let's compare the services. Event Grid is great for reactive programming. React to status changes. Event Hubs are for streaming series of events, like big data pipelines. Service Bus provides high-value enterprise messaging, order processing, and financial transactions. Storage Queue is simple, cost-effective, support large volume for messages. For example, in e-commerce, Service Bus can process order placed. Event Grid can trigger shipment created. Event Hub streams the telemetry for analytics. Let's see how we can integrate MQTT data. We can use Event Grid to route the telemetry from our IoT devices to Event Hubs and then into Azure Stream Analytics to gain insights from our device telemetry. We have another solution that is a perfect fit for IoT deployments, IoT Hub. This is a specialized hub for IoT devices, especially when we need per-device identity and bidirectional communication. If we only need event ingestion, Event Hubs might be enough. but IoT hubs provide us the device management and richer device features. Let's say we work in a large retail environment where IoT is deployed. The shelves has sensors monitoring the products for replacements. The aisle has cameras monitoring the people flow taking items off the shelves. The combination of the sensors and the cameras help make the restocking of shelves quickly and efficient. To reduce latency, protect backends, and standardize access, we design an application optimization solution. Let's talk caching. So we have a user that tries to access our website. Our website needs to retrieve data from the database. Instead of reaching all the way to the backend, we can create a cache solution in between them to increase performance and availability. Now, the website first checks if the data is in the cache. If not, it will go ahead and retrieve the data from the database and will store it in the cache. This is intended for frequently accessed data that doesn't change frequently. Then, we'll put it in the cache for future use with minimum latency. Cache is great for distributed cache, session store, or as a message broker. From tier perspective, there are 4 tiers of Azure Managed Redis, each with different performance characteristics and price levels. Azure Managed Redis is a fully managed in-memory data store based on Redis. It is great for caching, the session state, real-time analytics, and even a lightweight messaging patterns. We get here very low latency, reduce the backend load, multiple tiers are allowed for cost and performance optimization. We also support security and high availability options. Let's take a login session storage, for example. Keeping the session state in Redis, make your web app tier stateless, so auto-scaling becomes easy. There is guidance and migration planning for Azure Cache for Redis. Check it out if you're working with that solution. What about APIs? Azure API Management is your API front door to publish, secure, maintain, and analyze APIs underneath one management native umbrella. How does that work? Clients call the Azure API Management solution. Azure API Management applies policies for authentication, throttling, transformation, login, and then routes to the backend APIs. That allows us central governance, consistent security, easier compliance accommodation, analytics, and protection from abusive traffic. Let us explore the API Management landing zone architecture. Public IP addresses are assigned to an application gateway, which will serve as the entry point for all external traffic. That endpoint exposes APIs through a custom domain. The application gateway is deployed on its own subnet, protected by a web application firewall policies to inspect and filter incoming requests. Traffic is routed from the application gateway into API Management solution, which reside within a separate API Management subnet. The API Management instance is configured in internal mode, which prevents direct public access. Private endpoints are used to securely connect the API Management to the backend application servers that are exposed only to the virtual network. API Management also periodically connects dependencies such as your Key Vault. Typically, all this private connectivity occurs within endpoints in a dedicated private endpoint subnet. Log Analytic workspaces and application insight integrated for logging, monitoring, and telemetry. Now, we shift into the lifecycle. How you deploy consistently, manage configuration safely. We design an application lifecycle. Infrastructure as a code means your infrastructure is defined in files and provisioned automatically. Same environment every time. The key is consistency. It allows to prevent configuration drift, enable repeatable environment, support early testing in prod-like setups. Azure support multiple infrastructure as a code deployments, such as ARM templates, Bicep, pipelines, GitHub Actions, Terraform, and Jenkins. The key here is to automate, standardize, and make changes reviewable. This provides us with faster deployments, fewer manual errors, consistent governance. How do my apps get consistent settings safely? We can use Azure App Configuration for application settings and feature flags, centrally managed. How it works? Applications read configuration values from a central store. We can manage feature flags, do point-in-time snapshots, compare configuration sets, and secure access using managed identities, role-based access control, plus encryption management. That will provide us with easier rollback and stronger security posture. While any application may use app configuration, distributed apps gain a higher benefit. That includes but not exclusive for microservices based on AKS, Azure Service Fabric, or other containerized application deployed in one or more geographies. That can also serve well serverless apps, which include functions or other event-driven stateless compute applications. In development environments, app configuration consists of Visual Studio, Visual Studio Code, and Azure CLI. Those components are linked to Microsoft Entra ID, App Configuration, and Azure Key Vault. In production environment, Azure App Configuration consists of Azure Entra ID managed identities for the resources with related Azure services. These components are linked to Microsoft Entra ID, App Configuration, and Azure Key Vault. Time to review what we learned. In our use case, Tailwind is looking to update their website to include customer-supplied product images, in addition to the already existing photos provided by marketing. Uploaded images will need to be scanned before posting on the website. That will be done with an in-house developed API. They would like to send a thank you email after a successful upload. It is critical that the service hosting the application supports rapid auto-scaling and high availability with minimum costs. Where should the images be stored? How will you ensure that all images are scanned, even when uploads are outpacing scanning? Once images are approved and the catalog database is updated, how will the consumer will be notified? Let's see an example solution. First, we will choose what will be the image storage. Those can live in a blob storage, highly flexible for that kind of scenario. Then, we need to consider the notification. We can handle that with event grids. Then, we need to consider how the event will be stored. We can use Service Bus for push delivery to make sure that all the requests will hold until my API will be ready. In order to send the messages to the scanning, we can use Azure Functions. Then, we need to send an email. We can use Logic Apps for that. In this session, we covered describe message and event scenarios, design a messaging solution, design an event solution, design an application optimization solution, and design application lifecycle. This concludes our session. There are many ways to continue your learning journey. We encourage you to watch other videos in this course or search out your next favorite topic on Microsoft Learn at aka.ms/learn. I'm Amit Neil. Happy learning!